Okay, back with structure and interpretation of computer programs, and we continue with the section 3.2, the environment model of evaluation. So when we introduced compound procedures in chapter 1, we used the substitution model of evaluation to define what is meant by applying a procedure to arguments. So to apply a compound procedure to arguments, evaluate the body of the procedure with each formal parameter replaced by the corresponding argument. Once we admit assignment into our programming language, such a definition is no longer adequate. In particular, section 3.1.3 argued that in the presence of assignment, a variable can no longer be considered to be merely a name for a value. Rather, a variable must somehow designate a place in which values can be stored. So I think this is a reference to the fact that a variable, in a sense, indicates or represents a place in the memory of the computer. So in our new model of evaluation, these places will be maintained in structures called environments. An environment is a sequence of frames. Each frame is a table, possibly empty, of bindings, which associate variable names with their corresponding values. A single frame may contain at most one binding for any variable. Each frame also has a pointer to its enclosing environment, unless, for the purposes of discussion, the frame is considered to be global. The value of a variable with respect to our environment is the value given by the binding of the variable in the first frame in the environment that contains a binding for that variable. Not very clear all these environment binding, etc., but I hope it will be a bit easier to understand by continuing. If no frame in the sequence specifies a binding for the variable, then the variable is said to be unbound in the environment. Okay, so for example, if you just declare a variable without assigning a value to it, is that the case of the unbound variable? I don't know. Figure 3.1 shows a simple environment structure consisting of 3 frames, labeled 1, 2, and 3. In the diagram, A, B, C, and D are pointers to environments. C and D point to the same environment. The variables Z and X are bound in frame 2, while Y and X are bound in frame 1. The value of X in environment D is 3. The value of X with respect to environment B is also 3. This is determined as follows. Let me check one thing. Okay, everything is okay. So this is determined as follows. We examine the first frame in the sequence, frame 3, and do not find the binding for X, so we proceed to the enclosing environment D and find the binding in frame 1. On the other hand, the value of X in environment A is 7, because the first frame in the sequence, frame 2, contains a binding of X to 7. With respect to the environment A, the binding of X to 7 in frame 2 is said to shadow the binding of X to 3 in frame 1. The environment is crucial to the evaluation process because it determines the context in which an expression should be evaluated. Indeed, one could say that expressions in a programming language do not in themselves have any meaning. Rather, an expression acquires a meaning only with respect to some environment in which it is evaluated. Let's finish this paragraph and then let's look at the figure 3.1. Even the interpretation of an expression is as straightforward as plus 1, 1 depends on an understanding that 1 is operating in a context in which plus is the symbol for addition. Thus, in our model of evaluation, we will always speak of evaluating an expression with respect to some environment. To describe interactions with the interpreter, we will suppose that there is a global environment consisting of a single frame with no enclosing environment. That includes values for the symbols associated with the primitive procedures. So for example, the idea that plus is the symbol for addition is captured by saying that the symbol plus is bound in the global environment to the primitive addition procedure. Okay, I got it. Let's see at this figure. So alphabet letters A, B, C, D represents environments, while Roman numbers 1, 2, 3 represents the frame. And x dot, for example, x dot 3 represents that the value 3 is bounded to the variable x. Okay. What's the shadowing here? Okay, with respect to environment A, the binding of x to 7 in frame 2 is set to shadow the binding of x to 3 in frame 1. Yeah, okay. So basically, here x is shadowing the binding of 3 to x in frame 1. Okay, not totally clear to be honest, but because I do not understand, I mean, the environment, what's the environment? I mean, practically speaking, what's the environment and what's the frame? Because theoretically everything is clear, it's almost clear, but practically speaking, I still don't see what environments and frames represent when you actually you are actually coding. But let's continue. Section 3.2.1, the rules for evaluation. The overall specification of how the interpreter evaluates a combination remains the same as when we first introduced it in section 1.1.3. So to evaluate a combination, we evaluate the subexpressions of the combination, and we apply the value of the operator subexpression to the values of the operand subexpressions. Okay. The environment model of evaluation replaces the substitution model in specifying what it means to apply a compound procedure to arguments. In the environment model of evaluation, a procedure is always a pair consisting of some code and a pointer to an environment. Okay, so a procedure is always a pair consisting of some code and a pointer to an environment. Because we said before that a procedure makes sense only if considered inside an environment. So procedures are created in one way only, by evaluating a lambda expression. This produces a procedure whose code is obtained from the text of the lambda expression, and whose environment is the environment in which the lambda expression was evaluated to produce the procedure. So for example, consider the procedure definition of the square evaluated in the global environment. The procedure definition syntax is just syntactic sugar for an underlying implicit lambda expression. It would have been equivalent to have used it would have been equivalent to have used defined square but using lambda x. We saw the lambda expression. So we are defining environment structure produced by evaluating, okay, in the global environment. Okay, which evaluates the lambda expression and binds square to the resulting value, all in the global environment. Figure 3.2 shows the result of evaluating this defined expression. The procedure object is a pair whose code specifies that the procedure has one formal parameter, namely x, and a procedure body, which is multiply x star xx. The environment part of the procedure is a pointer to the global environment, since that is the environment in which the lambda expression was evaluated to produce the procedure. A new binding, which associates the procedure object with the symbol square, has been added to the global frame. In general, define creates definitions by adding bindings to frames. Still not clear what are frames, and someone is ringing at the door, so I have to open him or her or them. Okay. Enough with neighbors and go back to structure and interpretation of computer programs, which is way better, even if totally unclear at the moment. We are dealing with frames environment, and I still don't have a clue of what those terms practically mean. So, where we are. Where are we, should I say, probably. Okay, a new binding which associates the procedure object with the symbol square has been added to the global frame. In general, define creates definitions by adding bindings to frame. Okay, creates definition by adding bindings to frames. Cool. So now that we have seen how procedures are created, we can describe how procedures are applied. The environment model specifies to apply a procedure to arguments, create a new environment containing a frame that binds the parameters to the values of the arguments. The enclosing environment of this frame is the environment specified by the procedure. Now, within this new environment, evaluate the procedure body. Figure 3.3 shows the environment created by evaluating square 5 in the global environment. Okay, I can see that there is this E1, which is environment. One is the frame. Um, so because square is defined the global environment. The square 5, there is a new environment with a new frame where the value 5 is bind to the variable x. Is that the meaning? I still don't know. I still don't know. To show how this rule is followed, figure 3.3 illustrates the environment structure created by evaluating the expression square 5. So the fact is that it looks like that environments and frames are created by evaluating expressions. So the environment structure created by evaluating the expression square 5 in the global environment, where square is the procedure generated in figure 3.2, and square is defined in the global environment, if I'm not wrong. But let's go ahead. Applying the procedure results in the creation of a new environment. So by applying a procedure, we create a new environment, labeled E1 in the figure, that begins with a frame in which x, the formal parameter for the procedure, is bound to the argument 5. Cool. Okay. The pointer leading upward from this frame shows that the frame's enclosing environment is the global environment. The global environment is chosen here because this is the environment that is indicated as part of the square procedure object. Within E1, we evaluate the body of the procedure, and since the value of x in E1 is 5, the result is star 5, 5, or 25. The environment model of procedure application can be summarized by two rules. A procedure object is applied to a set of arguments by constructing a frame, binding the formal parameters of the procedure to the arguments of the call, and then evaluating the body of the procedure in the context of the new environment constructed. The new frame has its enclosing environment, the environment part of the procedure object being applied. A procedure is created by evaluating a lambda expression relative to a given environment. The resulting procedure object is a pair consisting of the text of the lambda expression and a pointer to the environment in which the procedure was created. We also specify that defining a symbol using define creates a binding in the current environment frame and assigns to the symbol in the indicated value. Finally, we specify the behavior of set, the operation that forced us to introduce the environment model in the first place. Evaluating the expression set variable value in some environment locates the binding of the variable in the environment and changes that binding to indicate the new value. That is, one finds the first frame in the environment that contains a binding for the variable and modifies that frame. If the variable is unbound in the environment, then set signals an error. These evaluation rules, though considerably more complex than the substitution model, are still reasonably straightforward. Moreover, the evaluation model, though abstract, provides a correct description of how the interpreter evaluates expressions. In Chapter 4, we shall see how this model can serve as a blueprint for implementing a working interpreter. The following sections elaborate the details of the model by analyzing some illustrative programs. So let me stop here and I will continue right after.